Hey all. So, a couple of you had questions on using the special right triangles that we went over on Friday on the homework assignment this weekend. So I thought I'd do some examples. So I'm going to do 8, 10, and 12, one of the 30, 60, 90s, then the 45, 45, 90, and then 12, which has both. Anyway, starting with number 8. First of all, let's draw a model. We know in general that if the triangle is aligned like this, so that there's the right angle, there's 30 degrees, and there's 60 degrees, just like it is here, that the ratio of the sides of the triangle will follow the form x, 2x, and x root 3. Okay, so I can see here that I've got 5 as the hypotenuse in the portion of the ratio where 2x should be. So I can solve for x by saying 5 equals 2x. Excellent. Now let's solve for x. 2, x equals 5 over 2. Okay, so now I can see here that if this is x, this is 2x, that y must equal 5 over 2. So that's one of my answers. Y equals 5 over 2. Then the third side is equal to the shortest side of the right triangle times the square root of 3. We proved that ratio using an equilateral triangle. So I can say, alright, over here, x root 3, in this side of the triangle, x equals 5 over 2 times the square root of 3. So I'll write that 5 root 3 over 2. I got that answer just by saying, alright, what's 5 over 2 times the square root of 3 over 1? And that's 5 root 3 over 2. Notice that it tells you to use radicals in simplest form, so that's why I'm leaving my answers as fractions and radicals. I'm not rounding, I'm not turning them into decimals. That way I have radicals in simplest form, which is what I was asked for. So that's number 8. Oh, number 10 is super easy. You guys can do number 10. Number 12. I'll do number 12. Alrighty. Number 12, I have a 45, 45, 90, and a 30, 60, 90. So I know, first of all, my 45, 45, 90, let's start out with a model, that the sides of the triangle look like x, x, and x root 2. So that means if this is 9 down here, that this also must be 9, because it's an isosceles right triangle. The base angles are the same, the legs must be the same length. 9 and 9. Okay, that's a good start. Now I know that the hypotenuse also must be 9 root 2. The length of the leg times the square root of 2. 9, if I could write, root 2. I'm going to draw an arrow because I can't write that small. 9 root 2. Excellent. Alrighty, so now I've got the hypotenuse of a 30, 60, 90 right triangle. And I want to find x. So let's draw a model of a 30, 60, 90 right triangle. Oh, and let's go ahead and align it the same way that one is, just so it's easier to see. So there's 60 degrees, and there's the right angle. Down here is 30 degrees, and we know we want x, and this is 9 root 2. Well, let's right here do the model. Sorry. In the model, this is x, this is 2x, and this is x times the square root of 3. Excellent. So I want to get, if 2x equals 9 root 2, what does x root 3 equal? Because I know this side, 2x, and I want to get this side, x root 3. So let's do that. So I know 9 root 2 equals 2x. Great. So that means x equals 9 root 2 over 2. And then I want the side that has x times the square root of 3. I could add this in here. I know this side is 9 root 2 over 2. And now I want to get this side. So I'm going to say, alright, multiply it by the square root of 3. So this times the square root of 3 is 9 root 6 over 2. And that's my final answer. 9 root 6 over 2. In simplest radical form. Excellent. So that was a little review of using 30, 60, 90 right triangles and 45, 45, 90 right triangles, the special right triangles, to solve for missing lengths. Hope it helps.